Let's talk about metamerism. Isomers which differ from each other in the hydrocarbon chain present on either side of functionality, we call them metamers. For instance, the two molecules contain a ketonic functionality. Now, in the first molecule, on either side of that ketonic group, we have methyl, and on the other side, it's a propyl group. So, the name is methyl propyl ketone. But in the second case, we have ethyl group on either side of that functionality. So, the name is diethyl ketone. Now, the two isomers differ from each other in the hydrocarbon or alkyl chain present on either side of that ketonic group. So, these are metamers. Now, to identify metamers, following conditions are helpful. Number first is isomers must belong to same class, that is, they must possess same functionality. Second condition is isomers must contain non-terminal functionality, that include a ketonic group, an ether group, a thioether group, an ester group, as well as a secondary amine. All these functionalities are non-terminal, so they can be the candidates for forming metamers. The third condition is isomers must differ only in the hydrocarbon or alkyl chain on either side of that functional group. So keeping these conditions into consideration, let's look at some of the examples. In these two molecules, the functionality is an ether. Now, in the first molecule, we have a methyl group on one side and a propyl group on the other. But in the second isomer, we have an ethyl group on both sides. So these two molecules have same molecular formula. They belong to same class, that is having same functionality, that is ether, but they differ from each other in the hydrocarbon or alkyl chain on either side of that functionality, so they are metamers. In the same way, while looking at these two molecules, they are having an ester functionality. On either side of that functionality, one molecule contains a methyl and a propyl group, but in the next we have an ethyl group. So these two molecules belong to same class, that is, they possess same functionality, that is an ester group, but they differ from each other only in the hydrocarbon chain or alkyl chain present on either side of that functionality, so they are also metamers. Now, point to be noted is metamers can be position isomers also, provided main chain must not change, because in position isomerism only the position of functionality changes, not the main chain. For example, we have these three molecules. All these have ketonic functionality. Now the first molecule is 2-pentanone, the next is 3-pentanone, but the third one is 3-methyl-2-butanone. Now in the first molecule, that's A, we have on one side methyl group, but on the another side we have a propyl group. In the next molecule, we have on both sides an ethyl group. In the third case, that is C, we have on one side methyl group, but on the another side we have isopropyl group. So all the three molecules differ from each other only in the hydrocarbon or alkyl chain present on either side of functionality. Clearly, all these are metamers. But while looking at A and B, main chain is same, that's of 5 carbon atoms, but they differ from each other in the position of functional group. That is, in the first molecule it's at 2 position, in the next it is at the 3rd position. So A and B are position isomers also. I hope you understand this. If you like my videos, please subscribe. Thank you.